First, we measured the spring constant K by hanging the weight from the spring and measured the stretching distance.
Y2 was 4.5 inches and Y1 was 2 inches. So K equals 2 pounds over 4.5 minus 2, which was 2 pounds over 2.5. And overall K equals 0.8 pounds per inch.
As you can see here, when the motor moves, the block lifts up, and in order to fix this, we added this little piece. So when the motor goes, the block no longer lifts up and is able to continue. Here we are stopping the block right at this point so we can trace the springs in order to find data to further find the force that the block will hit the marble at. Now that the block is back in its original place, we now have to draw the horizontal line. So we are able to measure the horizontal and then the vertical. So we are able to use Pythagorean theorem to find theta. And we measured the horizontal as 2 inches and then the vertical as 1 inch. So to find this, it would be tan theta equals 1/2. So theta will equal tan inverse of 1/2, which will give us theta equaling 26.6. Right here, we're showing the math of how we calculated forces. First, we found the total force, which is equal to K delta S. We already found K, which is the spring constant, and then delta S was S2 minus S1. And then to find the Fy, you do Ft cosine theta. So we plugged in Ft and then cosine theta being the 26.6, and we got Fy. Right here, we're measuring that piece of block because we were trying to find the torque, and before torque, we were trying to find the F net, which is 2Fy. So to finally find torque, we did F net, which was 3.68 times 2 1/16, which was the length of the block, to be 7.59 pound-inches.
Next, we turned on the motor and took the time for 5 revolutions to find the RPM. And it was 5 revolutions equals 4.05 seconds. So 1 revolution equals 0.81 seconds. And the total RPM was 74.07.
pushed all the way back, the whole system was at potential energy, and then when it was released, it turned into kinetic.
Here we're finding the velocity, so when the marble went 4 feet, we timed it as 0.75 seconds, and velocity is distance over time, so it was 4 over 0.75, so velocity is 5.35 feet per second. After we found velocity, we were now able to find the kinetic energy, that being 1/2 mv squared. We Googled how much a marble weighed and plugged it in for m, and so we were able to find kinetic energy by using the velocity we had already calculated. Finally, we found how much current was in the circuit, and then we found how much power by using our current, and we calculated how much power because we were trying to find torque, and we were attempting to find torque because we wanted to make sure that the torque of the motor was more than the torque caused by the springs, and if the torque of the motor is more, that means it's able to pull the block back.